Hello everyone, welcome back to another video. So today we are going to discuss editorial for Codeforces around 999, day 1 plus day 2, which was there on yesterday, and it was a pretty interesting contest, I would say. All questions were quite tricky, and maths greedy based questions were there, and I solved first four problems, and I had a good good rank, I would say. 1787 was my rank in Div 1 plus Div 2. I got positive delta, but I, looking at my submissions, you can clearly see that there were some wrong uh, four penalties. I got one penalty on A itself, then two penalties on D, and one penalty on C. So this was a mistake from my side. Similarly, the for C, I also made a stupid mistake. For D, I think it's okay because there the my logic improved from each test case, but in A and C I made unnecessary penalty. Let's just start with editorial. So first problem what we are given is an integers a1 a2 up to an and sum s is initially 0. Now Kevin performs following operation for I equal to 1 2 in increasing order. So whole array from left to right, and whenever Kevin is at ith position, he adds AI to S, and if resulting S is even, then Kevin earns a point. And then what Kevin does is keeps dividing keeps dividing S by 2 until it becomes odd. Now Now Kevin also earns at most 1 point in each operation. So the points earned in at an index can max be 1. It does not depend on the steps which it took to divide s by 2. Now, since these divisions are considered more beneficial for Kevin, we need to arrange the array such that uh, total number of points is maximized, and we need to basically print the maximum number of points that are possible. So these are the test cases. Let me show you one test case first. 2 and 1 2. So n is 2 and array is 1 2. Now if we arrange this array as 2 1, we get answer as 2. Now how we get that? So initially s is 0, and at this position s is 2. So as it's even, so we get +1 at index 1. Now after 2 becomes 1 after dividing it by 2 until it is odd, so 1. Now we move to next index, that is here, and initially s right now is 1. Here initially s was 0. 0 plus 2 becomes 2, and then it gets divided. Initially s was 1, add ai to that s, so s becomes 2. Again this is even, so +1 point we get, and we divide it by 1, and we go to move to next index. There are no more elements, so total score here is 2. You can also go through other test cases, but right now I will just move to the observations. The first observation is that at index 0, initial s at 0, so initial value of s is 0, so s is even when we are entering index 0. Now, second, at any other index, the value of s will always is always odd, because our exhausting condition at each index is to keep dividing s until it becomes odd. So whenever we are moving to next index, s will always be odd. Now let's say s is odd, and what we are moving to index I such that ai is even. Whenever ai is even, odd plus even, s plus ai will remain odd and we will not earn any point. Similarly, if we go to so basically if we move to an even index, when s is odd, then we don't earn any point. But initially when s is even, that is when s is 0 at 0th index, then we gain a 1 point, because initially s is even and ai is also even, and s plus ai is even, so we gain 1 point here. Here we gain 0 points. Now when s is odd and it moves to ai such that it is odd, then we gain we gain 1 point, because s odd plus odd will become even and we will gain plus 1 point. Now no more than one even element will contribute to our score, because we can only keep one element at starting index, and all other evens can be at any position but their contribution will be 0, and all the odd elements will always contribute 1. So let's call even as even number of elements and odd as odd number of elements in our vector. Now if even is 0, this is also an condition, because if there are no even elements, then we can't put even at starting position, so that arrangement is not valid. The only possible arrangement here is to keep all the elements odd. Now in this case, what would be my answer? So first of all, s is 0, so odd plus even, odd, so we gain 0 points. Now this is odd, s will always be odd when we are entering later positions, so odd plus odd becomes even, so here we gain 1 point. S again becomes odd, odd plus odd again even, plus 1, but after dividing it by 2 it becomes odd, goes to next index, so plus 1. This keeps happening. So how many what is the total score which we got? It's n minus 1. So when even number of even elements in the array is 0, then our answer is n minus 1. Now else, when even is greater than 0, that means we can put at 0 index an even element, and we can put all other odd elements here, but and any arrangement can be possible after this. Now in this case, what would be my answer? So s is 0 at first index, we gain 1 point. Now whenever we are moving into an index odd element, that is whose index is not 0, we will always gain a point. So basically at all positions where there is an odd element, we will gain a point, plus 1 point which was gained at 0th index. So here answer would be odd plus 1. Odd is the number of odd elements in the array, and 1 is the contribution of 0th index, so that first even number. So this is the solution. If even number of even elements is 0, and minus 1 is the answer. If even is positive, then Number of odd elements plus 1 is the answer. So talking about the code, first of all, I have declared a vector and I have declared two variables basically which I'm using, answer and ch. Now ch is to just check if there are even elements present in the array. So if a of I mod 2 is 0, then I am just updating ch equal to 1. And if a of I mod 2 is 1, that means I am just incrementing number of odd elements. Now if ch is 0, that means there are no even elements. I am just printing n minus 1. Else I am printing answer plus 1. That is odd, number of odd elements plus 1. Pretty easy question, I would say. I got first wrong case when for the first test case here I was printing 0 instead of n minus 1. I I thought answer would always be 0 at initial idea, but then I did some I I run my solution on sample some test case and found that the answer here would be n minus 1 and then updated the solution. Now second problem is also pretty good, I would say. So Kevin has n sticks with length a1 a2 up to an, and Kevin wants to select 4 sticks from these to form a isosceles trapezoid with positive area. And rectangles and squares are also considered as isosceles trapezoids, and we need to find a solution if there exists, and if there exists no solution, then we can put minus 1. So first of all, let's try to understand what a isosceles trapezoid is. So trapezoid is of this type of structure where two opposite sides, so this and this are parallel, and this and this are of length equal. Say these two sides are same length. So let's call this length as c and c because they are equal. So and this a and b. So side a, it's parallel to side b, and other opposite sides are equal because of its isosceles property. So these two conditions should be satisfied. There is also an additional condition, but let's try to first understand one example. So first test case itself, that we have 5 5 5 10. This is the test case, and in this case what our answer what our trapezoid looks like is this. So these two sides are of length 5. The shorter side of parallel sides is 5 and longer side is 10. So here answer is 5 5 and 5 10. We basically first print we basically first print the opposite sides which are equal, then we print the base, these two sides. Now what what is important here is that when this condition becomes minus 1, so in fourth case, let's say third case is minus 1 because there are no two equal sides. Now how to check for fourth case? So fourth case is we have four integers 1 1 3. Now opposite sides always will be this will be opposite sides because that is the only option 1 1. Now smaller side would be 1 and this would be its bigger size. Now try to understand why this doesn't form a trapezoid. So we basically create a right angle starting from a vertex of the smaller side of that two bases and cut it to the bigger side. Now what would be this length? Because trapezoid is symmetric, so we can call it as x and this would be 1. So basically x would be length of larger side minus length of smaller side divided by 2. So basically it would here be 1. Now just break down this triangle. So it would look something like this. So this is 1, also this is 1. Now if you try to use just basic observation here would be why there is no value of y such that it forms a triangle. Now if you try to use Pythagoras formula, you can do that. Y will basically here come out to be 0, and if y is 0 this triangle will not form, and if this triangle is not forming, this does not become a trapezoid of positive area. This would just become a straight line. So that's why the condition fails. So what would be the satisfying condition here? So to generalize this, let's call it as C. This is A, this is B. We make this perpendicular. This would come out to be B minus A by 2 based on the previous observation. Length of larger side minus length of smaller side divided by 2. And let's call it X for simpler understanding. Now this is Y and we need Y to be positive. We need Y to be positive. So use the formula. So C square equal to Y square plus X square. So C square minus X square should be equal to Y square. Now if we want Y to be positive, we can simply break down this solution that if Y is positive, that means C is greater than X, because only then this condition will satisfy when C is greater than X. Even if C is equal to X, Y would be 0 and it will not form a trapezoid of length positive. Now what we want is C should be greater than X, and X is basically the difference between two sides of opposite sides. Now what is the most optimal value of C such that we can always form a trapezoid? Because we need C as max as possible, we need to pick maximum element from array such that frequency of C so there are at least two elements equal to C, because we need two seeds, right? One to make this side and one to make this side. So C is sorted. C should be the maximum value which is possible, and that would be the most optimal choice to always make a trapezoid. Now B minus A by 2 is the X value. Now X value should be as minimum as possible. So this should be as minimum as possible. They can also be equal because when they are equal, it will basically form a square, and square is also a trapezoid. Now, if we want b minus x to be minimum, then b minus a should also be minimum. That means absolute difference of b minus a should be minimum. So b minus a should be as close as possible. Then our x value would be minimum. So final solution look like this. So if we are trying to create a trapezoid of sizes like this, so C should be maximum with frequency 2 greater than equal to 2. So there should be at least 2 occurrences of C in original array, and B minus A should be minimum. We need to achieve these, and once we have those two values, we need to check that C is greater than equal to B minus A by 2. Now to avoid the double involvement of double data type, because this can be in 0.5, so if this is b minus a is odd, then this would go in a double, this will basically go into double data type. So we just check if 2 into c is greater than equal to b minus a, multiply 2 on both sides, this equation will remain consistent. So this is our final solution. Let me show you the code, how I implemented it. There could be a better way, but I did it in this way. First of all, taking inputs. Second is I have declared a map to store its frequency. Then I'm iterating over A and finding basically incrementing every element's frequency. Then I have declared a mx variable, which is just to find the maximum variable which has frequency greater than equal to 2. So if c dot second is greater than equal to 2, mx is max of mx comma c dot first. Now if mx is minus 1, that means I couldn't find any element which has frequency greater than equal to 2. So the first condition itself satisfied, which is that we need at least two equal elements, at least one pair of equal elements. So we just print minus 1 in that case. Now these two elements are being used as C, because those are the maximum values in the array, such that we have its two or more occurrences. Now what I'm doing is I'm creating a vector B after removing these two elements. So here from map I have decreased its frequency by 2. Then I'm iterating over the map and creating the B vector. Now how I'm doing it? So let's say we have uh, 3 occurrences of 1, 2 occurrences of uh, 5 occurrences of 2, and 1 occurrence of 3. So what I will do is I will basically push 1 3 times, then 2 5 times, and then 3 1 time. So this is how I'm creating a vector. Now this complexity might look like an n square, but I know that this count of frequencies will be always less than equal to n. That is the size of initial input array. So the complexity here would be O of n, not O of n square. Then after creating such B, I've sorted it. I don't need to sort it actually, as the map I'm using is ordered and all the elements are already sorted. Then what I'm doing is I'm iterating over sorted array. Now, as we need b minus a to be minimum, then their positions would be as close as possible in our vector, in the sorted vector of this. So this should be neighbors in that vector. So I'm basically finding the difference. So b minus a, I found b minus a in the diff variable, and then I'm just checking if 2 into mx, that is 2 into c, is greater than b minus a. If it is, then I'm just printing the four values. And if I don't find any pair such that it satisfies this condition, then I'm printing -1. This was the second question. I think this observation was very important of this 90-degree triangle, and what at what condition this fails, when this side's length becomes 0. So based on this, the whole solution was, the whole idea of the question was based on that observation itself. Now let's move to third one. Third one is very interesting. All the questions were pretty good, I would say. So in this question, what we are given is, we are given n classmates who stand in a line. Now the ith person from left says that there are AI liars. So the ith person from left says that there are AI liars to its left, not including themselves. So this is given, and each classmate is either honest or liar, with the restriction that no liars can stand next to each other, and honest classmates always say the truth, and liars can either say truth or lies. So liars can say both, but honest classmates has to always says the truth. Now what we want is to determine number of distinct possible game configurations. We also have to do modulo this number, because the number of distinct possible game configurations can be a lot high. It can be of order 2 raised to power 2 into 10 raised to power 5, because at each position there is a possibility of the ith person is either uh, liar or honest. So two options on each index. So 2 into up to n, 2 raised to power n, which is a lot high. So we need to print modulo answer. Now let's just show you this third test case. So in third test case, what we are given is 5 students, and 00112 is the vector input. Now, so this can be 3 possible combinations. Now first is 00112. So blue marks honest people and red marks liars. Now 0 first two persons are honest, because first two person can be honest because there are basically no liars to its left. So at 0th index there is obviously no liar. So first person can be honest. Similarly, this person can also be honest. Now this person is a possibility here is a liar. Then this person is honest because there is one liar before it, and this person is liar. Similarly, these are the other possible combinations. So first is honest, second is liar, third is honest, fourth is liar, and fifth is honest. Similarly, this. You can try to understand this everything why this is correct. Now this seems like a pretty difficult question, at least for me. When I saw this, I thought that this is a pretty difficult question. I don't I was clueless at that time, but the main condition where I started understanding the problem was that this one, that no two liars can stand next to each other. So let's try to write observations here. So first observation, that let's say there are some elements before this and there are some elements after this, and I'm at index I. Now this can be either honest or either this can be liar. Now when we say this is a liar, that means this cannot be a liar and this also cannot be a liar, because no two liars can stand next to each other. So we know that this is honest and this is honest. Now based on this, try to find try to understand one observation, that let's say AI value of this index, that is I minus 1, would be, let's say it is as y. Now here we don't care because here we have fixed it as liar. Now this condition, what should be the value of I plus 1? It should be equal to y plus 1. Now why is that? Because this per I minus 1 and I plus 1 both are honest. Now let's say there are y liars before I minus 1. Now I is the additional liar, so number of liars increases, and at y that and at I plus 1 index, the number of liars should be y plus 1, because additional liar is coming from ith index. So based on this, you can solve the whole problem. So if I'm at ith position and I want to make this as a liar, so what I need to do is I need to check if a of I plus 1 minus a of I minus 1 is equal to 1. Then only I can set this element with as liar. Now once you set this, that means you automatically set its next element as honest. Now once this is honest, we just need to move to I plus 2. Move to I plus 2. So try to write a recursive solution basically. When I am at I index, I check the condition of liar and move to the I plus 2 index. Now if I have to put this as an honest, now this is also interesting part. Till now we have solved this problem of liars, putting liars into fixing liars at indices. Now whenever this liar whenever there is a liar, we move to I plus 2 index. So whenever we fix a liar, we always skip one indices. So if we are at index I and we have to put this as honest, that also means that I minus 1 is also an honest person, because if it was liar, so if we are moving by I plus 2, there is this its previous element is always honest. So if we have to put ith index as honest, then we must know that I minus 1 index is also honest. Now if both of them are honest and the value here is y, what should be the value here? It should be y itself, because both are honest and there is no liar in between them, so there should be consistency in their value, so both of them should be honest. Now these two conditions are enough to solve your problem, and you don't need to worry about the count of liars, because we are maintaining the count of liars here uh, from the start, so it will be consistent throughout the array. So this is the overall solution. So you write a recursive DP, and each state can be represented as only the index. So a linear DP. Now there are also base cases for index 0 and index and minus 1, but they can be easily figured out. So if we put L as liar, ith index as liar, we move to I plus 2 based on this condition. Now if we are putting I as H, that is honest, then what we need is A of I must be equal to A of I minus 1, and then we move to I plus 1, not I plus 2, we only move to I plus 1, because based on this we cannot say anything about this. So I hope this is clear. I mean, this is kind of intuitive, but uh, you need to understand these observations. Try to write the solution based on these observations itself. I don't think there is anything more to explain, and the base cases can be easily found from this explanation itself. So try to write your code by yourself first, and if you are not, then we can see the code. So first of all, I declared these global variables. I wrote a recursive DP. I think uh, this problem was not a standard type of problem. So I generally, for linear DPs, I write an iterative approach when the solution is more clear. But here, the solution was not clear for me. Not clear means in terms of iterative how transitions would look like. So I wrote a recursive DP. So I'm starting from 0th index. Now if I is greater than equal to n, then I'm what I need is basically return my 1. That means we found one combination. Now this is just memorization of DP. Now I declare an answer variable to store current answer. So I wrote two conditions for the base case. One is when I is equal to 0, other is when I is other than any other index. Now if a of I equal to 0, so for base case, if 0th index element is honest, that means a of I must be 0, because if this is honest and a of I is greater than 0, that is clearly wrong, because there are no elements before it, and he thinks that there are a of I liars before it, which is positive. So this is wrong. So the condition for 0th index to be honest is when a of I is 0. So when a of I is 0, we move to its next index. Now the condition for liar. Now liar is the condition when, first of all, what we need is we need if there is an element after it. Now for the condition where there is only one element, this can be honest, and this can be easily be liar, because we don't need to check the condition of the a of I plus 1 minus a of I minus 1 is equal to 1 when there is no element at right side itself. So this can always be a liar. So when I plus 1 is not less than n, we can say that he can be a liar, and we move to I plus 2 index. Now if there is an element at I plus 1 index, then a of I plus 1 must be 1. So this is zeroth index, this is first, and this is base case for I equal to 0. That's why I plus 1 only possible value is 1. Now, if this is liar, then this should be always honest. Now, what is the possible value of here AI at index 1? The only possible value is 1 because there are one liar before it, that is zeroth index element itself. So if that condition is satisfied, we move to I plus 2. So the base condition is done. Now for all other indices. Now for all other indices, for ith index to be honest, what we need is A of I must be equal to A of I minus 1 because of this explanation. Then we can put it as honest and we can move to next index. Now same code of above, that if I plus 1 is less than n. Now this is not I here is greater than 0, so there would be an element at I minus 1 index. So we basically need to check I plus 1 minus I minus 2 is equal to 1. If this condition is true, then we we set I as liar and move to 2 index above. Skip the next index because we already know that it is honest. Now if this is the last element, then it can be always be a liar. So we just move to 2 indices above. Finally store the answer at dp of ith index and return it. So this was the third problem. Coming to this, observations was difficult. Implementation wise, it was very easy. These types of questions pretty much gives idea about that a it is a DP question. Only what you only need is how can these conditions help. Now obvious solution of this is of length n cross n dp. So n is for indices and this n is for number of liars till I. So this is more obvious or naive approach. Now n cross n doesn't work here, so we needed it to optimize like this based on this condition. So this was the third one. Now we can move to fourth. In fourth question, what we are given is a sequence of length n, and what Kevin does is select two integers x and y from the set of integers such that absolute value of x minus y is less than equal to 1. Now erase them, then write down x plus y instead. Now Kevin wants to know if it is possible to make these integers into an sequence of length m, which is a sequence b of length m, to some sequence of operations. So what we are given is we are given two sequences. One is a, another is b. A is of size n, b is of size m. On sequence a, we can perform the above operation, that is we can select two integers x and y from that sequence such that the absolute value between two elements is less than equal to 1, and we erase both the values and add x plus y into that multiset, not exactly set, multiset. Now after performing some number of operations, we need to check if we can make a equal to b, and a, a sequence is equal to b when uh, they are both identical multisets. and m is less than equal to n, but n is of 2 into 10 raised to power 5. So first test case, try to understand. So we are given 2, 1 and 4, 5 and 9. So 2 is n, 1 is m, 4, 5 are elements in sequence A. This is A and this is B. Now we can, what we can do is we can remove this because their absolute difference is less than equal to 1, and add x plus y, that is 9. So here A becomes 9, B becomes 9, both are equal, so we print S. Yes, you can go through these test cases. I think these are pretty easy to interpret how the solution works. I will just move to my observations and solution. So first of all, there is n, there is m, a1, a2 up to an. Now, if we want, uh, let's try to take one test case. It will be better. So 1 1 3 3 3 5. This is one test case. Now, first operation which you will do, first step of your solution should be just to cut out the same elements. That is, this 3 can be satisfied by this 3. So we removed it. Now what we need to do is we need to satisfy this 5. So this is the first step. Now we need to satisfy the sum. We need to find a way of number of operations such that it satisfies condition 5, the value 5. Now if you go from try to create 5, how can we do that? Possible operation is we first do 1 plus 1, that is 2, and what we do is 2 plus 3, that is 5. So 1 plus 1 we are able to do because x minus y is 0 here, and 2 plus 3 we are able to do because it is less than equal to 1. Now only problem here is that, let's say I am at index, I have value 2 here, and further I have value 2 and 3. Now 2 can either be added to 2 and 2 can either be added to 3. Now we cannot generalize a optimize approach here. We cannot, because there are two possible operations. Either go to AI itself or go to AI plus 1. So we have two options. Now if we keep doing these two options every time, it would go out to be a 2 raised to power n type of solution. So instead of going to create 5, what if we what if we divide 5? So we need to divide 5. So 5 can be divided into 2 and 3. This is only possible division. This is only possible partition because 2 and 3 here has absolute difference as 1. So here is the second observation, that if bj is odd, then it can be divided into bj by 2 and bj by 2 plus 1. So 5 by 2, which is 2 in uh, floor value, and 5 by 2's floor value 2 plus 1 3. Now similarly, if there was 6, that means bj is equal, then we can do only one possible partition, that is bj by 2 bj by 2. So 6 can be divided into 3 3. So let's remove 6 for now. So 5 can be divided into 2 and 3. And what was our remaining set? What our remaining set was 1 1 3. Now 2, let's try to figure out how 2 can be satisfied. Now 2 can be divided by into 1 1, because bj is even and only possible configuration is divide them equally. Now this one can be satisfied by this one can be satisfied by this, and this. So this 2 is satisfied. Now we need to satisfy this 3. Now this 3 is already in set, so we don't need to divide it, and this 3 is satisfied, so our 5 is also satisfied. So now there are no set remaining elements in set 2, and also there are no remaining sets elements in set 1. So we print yes. So we basically need to simulate a solution. Now simulating a solution from a to b, that means trying to satisfy value of b according to a, is not generalized. It has multiple options. As you can see here, 2 can either be added to 2, also can be added to 3. So it is not an general optimized approach. But while going from B to A, there is only one option. So if it is odd, then we only have one option to divide it. One is bj by 2, other is bj by 2 plus 1. Now if it is even, again we only have one option to divide it by bj by 2 and bj by 2. So here the strategy should be going from B to A, not going from A to B. And how to implement this? The hint is in the question itself, by multisets. So I will show you my solution. I think there is not a lot of logics, because that's why I'm not explaining the handwriting of that code. I just explained the logic and I will show you the code itself. So first of all, take inputs. Then I have declared two variables, two multisets. One is st and one is st2. St is for a, st2 is for b. First of all, I am inserting all the elements from a into that multiset st. Then I have declared a remove variable. So it basically stores the common elements at the start itself. How do I do that? First of all, I am inserting elements into st2 from b. Now if I find that there is a common element in st itself, then I am removing that element from original set. Now we cannot remove it again from st2. I'm not sure that would be a good idea that we remove at this position itself, because this is an iterator. So removing it can give me some errors. So what I am doing is I need to remove them in future. So for now I am storing it into a vector of called as remove. Now all these elements are already being satisfied, so we need to remove them from st2 also. Now this is the more important simulation, that is we iterate um, uh, till both the sets have positive size. Now what we need is, from we get the minimum element from st2. Now this is the exhaust condition, that minimum element from st2 is smaller than the minimum element of a multiset itself. So what I'm trying to say here is that we need to satisfy 3 from, this is b's multiset element, and a here is 4 5 6 and up to 100, let's say. Now b is not present in a, so b cannot be satisfied from a. always, because the only possible further division can be 1 and 2, which is smaller than 3 itself, and we will never find 1 2 here. So this is the exhaustive condition. So if this condition is true, that means we cannot make a configuration, and so we print no itself. Now the target which we fixed, which we is being satisfied from second multiset, if that value is present in our first multiset, A is a multiset, that means both are equal and both of them are removed from our both the multisets. So those can be removed from both of them because both are equal. Else we don't find any same element in ST, so we break that element out. First of all, we remove it from our multiset, and what breaking does means if it is even, we break it down to two equal elements of value target by 2. If it is odd, we break it down to target by 2 and target plus 1 by 2. So this conditions. And finally, this for loop will end, and after ending, both of them should be of size 0, because then only both we need to make A equal to B, exactly equal to B. That's why both set size, all the values should exhaust uh, should satisfy from multiset A and multiset B both. If this condition is true, we'll print yes, else we'll print no. So main observation here is, instead of moving from A to B, we move B to A, because moving from A to B is not an generalized doesn't have a generalized optimized approach, but because it has basically two options what we can add from X. So 2 to 3, we can either add 2 to the existing 2 or 3 to the current 2. So we have two options. But while going from B to A, dividing it has only single option. So this was the main observation, and based on this, we simulate a solution and we print our answer. So this was the D problem. Difficulty wise, A would be 800, B can be 1100, I think, because it has geometry and maths in it, so can be 1100. C and D, C can be 1500 or 1600, because it was difficult to come to those observations, and D can be 1500. Yeah, C and D can have same difficulty. I tried to do E. My initial approach, not initial, but final approach, which I was trying in the contest, was using segmentary, but that is not the expected solution here. I will try to absolve it. Uh, and I guess that's it from my side. If this video was helpful, please let me know, and I will try to make as many tutorials as possible. Thank you for watching.